How did life on Earth originate? How to get energy in a family home economically and without great costs? How did a CO2 absorption device come about? What damages the Earth's climate the most? What is the difference between the effect of methane and CO2 in the atmosphere, and how does it affect temperature? How does a gas diesel engine work? Abolishing diesel engines in the climate crisis is really a solution? We also talk about all this with Associate Professor Marcela Morvová, who accepted our invitation for the interview. Now I would like to welcome Associate Professor Marcela Morvová from the Department of Environmental Physics, Department of Astronomy, Earth Physics and Meteorology, Comenius University in Bratislava. Welcome, Marcela.
Thank you.
So I would like to ask you, how did you start with the field of science, and what was the first momentum when you started to think in a green way?
At the beginning, I was a student of physics, and in the second year of study, I have got a project which was oriented to removal of polycyclic aromatic hydrocarbons from exhaust gas of cars. In reality, the person who gave me this project was an earlier student of my father. And my father, who originated plasma physics in Slovakia, gave this project to his earlier students, later cooperator, and he gave it to me. I have made the measurements on the Skoda 1000 MB, which was that time very popular car.
In which year it was?
1971.
Wow.
And they planned to measure it using paper chromatography, but in cooperation with my mother, I decided to make analysis using ultraviolet absorption spectrometry. And I have made calibration spectra for each type of polycyclic aromatic hydrocarbons. Most of them are based on benzene ring, which is cumulated. And usually, pyrene has 5 rings, 5 benzene rings, and on that it is added 1 or 2 additional benzene rings in the position, and there are numbers around the cycle, and usually it is 1, 2, other one is 3, 4, and then it is 1, 2, 3, 4 benzopyrene. New, most cancerogenic is 3, 4, which is now, the UPAC name is benzo-A-pyrene. And this one is in the biggest concentration in the exhaust of auto engine. Auto engine is fueled using petrol.
Yes.
And I have made calibration for these benzpyrenes, then coronen, fluoranten, chrysen, and some others.
And how good and how successful were the results when you were
You
doing
mean
that?
removal efficiency?
Yes, yes.
For most of them was removal efficiency higher than 99%.
Ah, amazing. Yeah.
And from this occurred my first patent, from these measurements. Then when I was looking after suitable time for my diploma work, I was contacting Health Ministry to find out if there exists some regulation in polycyclic hydrocarbons.
And it was the topic of your work.
I want it first. But they told me, why I am doing something such stupid? I have to do something useful. So I have asked, what is useful?
For them, yeah.
For them. And they told me that carbon monoxide. So my diploma work was oriented to the removal efficiency of carbon monoxide from exhaust using electric discharge. In that time, it was coronary discharge. I have built a 1 meter long discharge tube, and I have tested the removal efficiency and the product. it comes out that there occur a special type of products which have a polymeric nature. Later, when I was trying to have a PhD study, so I decided to test not only carbon monoxide, but also the mixture of carbon monoxide with water vapor, carbon monoxide with nitrogen, carbon dioxide with water vapor, and carbon dioxide with nitrogen, and combination of all three.
And what was the best from all those testings?
There was also one problem. I have changed also the material of electrodes. And it looks like that when I use copper electrodes, it occurs a special layer which has a very high dielectric constant, and this increase the catalytic effect. So
it was much more better with copper.
It was much better. The efficiency of removal of carbon monoxide using copper electrode and electric discharge was close to 100%. The best result later we have found out for better results than this for nitrogen oxides. There was such high that it was impossible to measure the residual concentration.
Really? So you couldn't do that?
Yes.
How you do the measurements? You must be very patient. How big is this process? How long it takes to measure?
In flowing regime, it was not so complicated because I have a possibility to take off the samples and measure it. But I want to know also the dynamic of the removal process and, of course, the necessary residence time in the system. For that, I have developed a special type of gas cell discharge tube. It was in reality infrared gas cell, inside which was incorporated the high voltage and low voltage electrode. So I put in the mixture, close the ventils, and then I have made zero measurement prior, and then I have reiterated, measured perhaps 30 seconds of discharge, then the spectra, and again. And from this, I have found out how it is changed. Because in first steps, the activated species are generated. Then the product is formed, but when it is very long residence time, the product begins to decompose. So it was very important to find the special time where it is the biggest efficiency and the acceptable product.
Yes, of course.
And it was necessary to do for various electrodes. And I want, of course, know what kind of products is produced, especially on low voltage electrode, because electric wind move all products to the low voltage electrode. Then I open it, put out the low voltage electrodes, and made the reflection and attenuated total reflection spectra in infrared region. From that, I know what kind of product is formed.
So it was really something what helped you at the beginning to form after decades the CO2 utilization?
I am using it still. Because when I have a new mixture of some exhaust, first of all, I made this measurement to find out how big should the system be and what will be the electrode distance, what voltage I will need, and how it will develop the product. Because I must estimate the residence time. And from this, I am able to estimate the residence time for the optimal work. Because system that I am testing usually contains a plurality of parallelly connected discharge tubes. Perhaps for 100,000 cubic meter, it is 430 discharge tubes.
And what was the result from all this work for the praxis?
In reality, when you want to build a system which is sourced by the real exhaust for exhaust source, you need to build a plurality discharge system, which the number of the system is coming out from the linear flowing velocity through the one discharge tube, and also residence time. This gives me the number of discharge tubes and the length of each discharge tube. In practice, without this measurement, it is impossible to design the system.
So it was, first of all, you needed to do that, all these measurements.
Yes, sure.
And what you see as the best thing, what was this best moment when you find out that this is something what is really great? And my question is also, if in this momentum you realized how was the beginning of life on the planet? Did these measurements change something in your mind?
It was very funny because my first measurements was scoped to dynamic mobile sources of exhaust. It means cars and similar. But as far as there was no possible to do some of these experiments, especially in smaller car, because when began to have an engine which is controlled using computer, my discharge make noise, which is not very good for the computer. So I was thinking to find where it is suitable to use and what kind of future application can be used. So at first I began to make measurements with the static exhaust sources. It is perhaps electric power station, heat power station, cement production, iron production, and similar. Very big piece of my life I give to cleaning of exhaust from glass production.
From glass?
I made a measurement with a connection of Glass Research Institute in Hradec Králové, and we have measured quite a lot of measurements on glass ovens, because there is very high concentration of NOx.
And you managed it, that it was in after measurement, you managed that it went for the lower?
I have prepared the design of the system for glass oven, have 1 ton of glass, but in the place I have made the measurements, they have 48 such glass ovens, but the owner was from outside, and they told that as to put such many finance to cleaning, although they have the measurements they buy and test my equipment, and in reality it was written as a best available technology. They told that they want to lie under the line where it is necessary to pay.
Yeah.
So they closed half of the ovens to be under the level.
Yeah, so
and not to build the system.
Yeah, so they didn't do that. Yeah,
Yes.
as it was
Yes.
as it was planned, but just because of financial process.
Yes,
Yeah,
yes.
to save the costs. Okay, and how you came then to carbon utilization?
Practically, all my prior measurements during my life was moving me to this.
Step by step, you always went by some flows.
Yes, it was something like when you are very quickly flowing river.
Yeah.
It brings you where you have to be.
Yeah, so you just take the chance and you was working on it.
I want to have a solid product, water insoluble, time should not decompose it, and it should be utilization.
Why utilization?
When you want to put money to something, you want to have usable product,
Yeah, of course.
not additional waste.
Yeah, what is usually on the market, yeah? What we can see.
Yes. It is problem to do something like that, but it was something that I want to do.
Yeah.
And finally, I find a way how to do. But at the beginning, maybe somewhat 1987, 8, when I had first my result from carbon dioxide, nobody want to have it.
Why?
Only-
Missing knowledge that time?
Missing knowledge and missing willpower.
Yeah, and maybe also people were not so worried
Only
like now.
after Kyoto Protocol,
Yeah.
it begins something which countries want to do. But up to now, there are not acceptable technologies which is suitable to do.
Yeah, but it's maybe also because of climate change.
Because from the point of climate change, most people think about adaptation, no about losing the problem.
Yes, to make the solutions for the problem.
Yes.
Yeah,
It
and
is
adaptation
problem
is
to
not
find the
solution.
solutions.
Yeah, so this what you find out is really solution
It should be solution.
for the planet. Okay, and when we look at the methane and CO2, what is the difference? Why, in point of view of climate change, people are always looking at methane and CO2? What is the difference? How
There
we
is one problem. People usually look at this, and most of climatologists look at this as like geometric optics. Sunshine come here, and they have only lines how it is going. But nobody thinks about what in reality occur in the greenhouse gases. And it is so that each gas which has absorption in infrared and radio frequency region means that this is excitation of bond energy, and it should be valence, deformation, or rotation energy, depends on the place where it is lying. But under this level doesn't exist more levels of energy, because when you look at it, you come from gamma to X-ray to vacuum, ultraviolet visible, infrared, and the radio frequency, and there is no more. So when sunshine comes to the greenhouse gas, and it is necessary to tell that each gas which has non-zero dipole moment has absorption in infrared area.
What does mean in practical life?
In practically that it absorbs the energy, but to come to zero level is not possible to do because it is prohibited. So the energy cannot do lower. So when I have excited perhaps carbon dioxide, the energy which got this molecule should be released other way. It is non-photo de-excitation. It doesn't exist. So the only possibility is using impact with other molecules. And during this impact, the excited molecule gives small part of its kinetic energy to other molecule. Perhaps carbon dioxide needs about 20 impacts to release all his excited energy. But in the case of methane and eventually other greenhouse gases, it is a higher number. But at atmospheric pressure, we have the mean frequency of impacts 10 to 10 impacts per second. And mean free path between two impacts is 1 micrometer. So it is very easy to release energy through impacts. And all greenhouse gases, it means carbon dioxide, methane, ammonium, carbon monoxide, freons, all chlorinated and fluorinated hydrocarbons, and some other, have a various value, so-called coefficient. And this perhaps for the case of methane, it is 21. For the case of carbon dioxide, it is 1, because it is so that it is divided to carbon dioxide.
And in a percentage in atmosphere, when we talk about methane and CO2?
Perhaps when I have 1 ton of waste, biological decomposed,
Yes.
then it releases during decomposition process 520 kilograms of carbon dioxide and 21% of methane. When I overcount is to kilograms, then from 1,000 kilograms I have 4,600 kilograms of greenhouse gases overcounted to carbon dioxide, so carbon dioxide effective.
Mm-hmm.
So from 1 ton I have 4.5 tons of greenhouse gases.
Yes, and methane is from that part only.
Yes,
this 21.
but methane is also from the decomposition from earlier time, perhaps in permafrost. And during melting of permafrost, this methane is released. Methane is also on the bottom of the lakes.
Always on the bottom, yeah.
Always on the bottom. In reality, methane is worse.
Methane is worse, yeah.
When a large portion of methane will be released from permafrost, it can be the end of life on the Earth, because the temperature will rise very strongly.
But not because of CO2, but because of methane. So that's why also your theory about utilization is much more useful for the planet, because you will manage
Perhaps
all this. Yeah.
Many people thought they don't eat meat because in cows' excrement gases
Yes.
is too much methane. But it is necessary to tell when we look on the
big picture
overview of the methane emission from cows and similar organisms, there is 7% of methane. But from the production of rice, there is 22%.
Only for the rice production.
Only from the rice production.
So it's much more bigger, because 7% from the cows.
And the people who are vegetarian, when they want to eat the rice, it is much worse than to eat the steak.
Yeah, because in this 22% of the methane is much more higher number.
Why it is necessary, the spectroscopist point of view? Because when during impacts increase the energy of each molecules, it means that it increases also the mean kinetic energy of molecules. And from the thermodynamics, it exists the definition that mean energy, kinetic energy of molecules, it is temperature.
Yeah, so that's why methane is much more dangerous.
No, that's why all excitation which decompose through impacts will increase the kinetic energy, and increase of kinetic energy means increase of temperature. It is physical process.
And what about
it is not to discuss.
Yeah, and what about prognosis? What do you think that if we stay as we are now on the planet with all what we produce, what do you think that how much could go higher the temperature of the planet?
In the case with it increased to 6 degrees of centigrade during perhaps 150 years, it means that some of the organisms will die, the sea level will rise up to 16 meters, and it means that countries which are lying very close to sea level, they lost a large portion of their land. Perhaps in the case of India, they lose about 1/3 of all their land.
So it will be a big amount of the land.
Yes, and you must think that how many people are living in the country which lose. Similar situation is in Netherlands.
Netherlands, yeah, because they are also lower.
In reality, the countries which in future will have the problem are the countries which are very much interested on the find suitable technologies which help.
Very dangerous in the future.
What we can do? First of all, we have to move to suitable renewable energy, which will be a portion of our energy portfolio. It is hard to tell that without nuclear energy, it will not be possible to have some results in this area.
Yes, so nuclear energy is necessary at this moment.
Till the time we have not the energy from fusion, we must use nuclear power stations.
Yeah, but we were talking also about the energies because you find out the possibility how to have a house full of energy and without cost because you did it at university already.
I have tried to store thermal energy. There are three possibilities how to store thermal energy. First of all, which use everybody, is to heat the water.
Yes.
It is so-called sensible heat. This heat is possible to have for 24 hours.
Yes.
Because then the temperature decreases. The second possibility is to use energy of phase change, usually the melting of suitable material. When we have perhaps as a source of energy vacuum solar systems for production of heat, then in the area between 50 and 60 degrees, which is very suitable for further application, we can store the energy in melting of paraffin. There is the problem because paraffin has a very low thermal conductivity. So it is necessary to add something to paraffin to increase its thermal conductivity. But storage is based on the energy of melting.
Yeah, and we are talking about paraffin. How big amount of paraffin you need, for example, for one house?
About 1.5 ton.
1.5 ton, and it's just once per lifetime.
It is for lifetime, and it is suitable for a house which is perhaps 10 times 10 meter and 2 steps.
Yeah, that's quite good as investment.
But during the winter, when it is very low sunshine, it's necessary to have additional source. Usually, perhaps for that 5 weeks, you need about 350 kilograms of wood.
Yeah, for the fireplace.
Which is not very big amount.
Yeah, for 5-6 weeks, yeah, you can manage that.
But there is a possible to have a system which don't need any fuel. And it means that you give additional possibility, which is so-called thermochemical energy storage.
Yes.
It is based on the crystals, which are hydrated crystals.
For example, which kind of crystals we can use?
Copper sulfide, which is copper sulfide plus 7 molecules of water.
Yeah.
During energy storage, you remove the water molecules, and from 7 to 1, then it changes the color of crystals, and it is energy stored. It is necessary, of course, pump the water vapor out, and it is not necessary to have a thermal insulation. It is only necessary to have a lower pressure.
Yeah.
And then when you want to have energy back, you give the water vapor
back,
and it releases the stored energy. In reality, it is so that when I compare water and phase change material, in phase change materials is about 5 times more energy than in water. And when I compare thermochemical energy storage, there is 10 times more than in water.
Oh, okay.
So when you have a combination thermochemical storage, phase change material, and the sensitive heat of water, you can have, when you have suitable source.
That's the best, when you have combination of all.
Yes, when you have perhaps residual heat from perhaps data storage, or heat from sunshine.
Collectors,
Yes, you can have energy whole year long. Without fuel.
That's amazing. You was testing that?
Yes.
On which big space at university?
I have a greenhouse which has a size about the family house.
And you was
I was heating it using 60 tubes of thermal solar system, and I have about 2 cubic meter of water, 1,6 cubic meter of paraffin. And now I am preparing experiments with hydrated salts.
Yeah, but it will be.
It will be in a very short time. I want to build it. Because it is cheaper to store energy in crystals than in paraffin.
It's much more better.
Yes.
Yeah, and when we are talking about storing energy, how many months are you able to storage? It's about 10 months when you can.
In the case of thermochemical storage, it in years.
So it can be there years.
I can have it as a reserve.
Yes.
And use a part of it.
So probably also for these 5-6 weeks in the winter time you can
use. In the case of phase change material, it is 10 months. In the case of sensitive heat, it's 1 day.
Okay. So the combination is the best when you have all of them. And you have zero cost just for the beginning.
It is only investment cost at the beginning.
Yeah, and if we are talking about investment cost, how much we could imagine that it will be necessary for one house, for example? How much we will need?
About 10,000 euros.
Okay, once.
Yeah. But when you are in productive age, you build it, and when you will be retired, you don't need to pay for thermal energy.
That's good. I would like to have it. Okay, that's such perfect. I would like to ask you, when we are talking also about this carbon storage, I will go back. Could you imagine that when you are doing this utilization, can we use it, for example, for the tunnels or for the houses? And when we do the utilization, what is the side products? What you see in the future? When we can use it?
I must go to the beginning.
Yes.
Because at the time, about 1990, I have begun to have experiments which are close connected to the origin life of Earth.
Yeah.
It is necessary to tell that at the time, most atmosphere was formed from volcans and also from moving of continents. In the contact of continents, there was released the nitrogen because the Earth crust was built from metal nitrides, metal oxides, and metal hydrates. Mm-hmm. Metal hydrates are existing in the very deep areas. Metal oxides are still existing in the coast. And metal nitrides were decomposed at the temperature close to 500 degrees. So the nitrogen was coming out from the contact of continents. In the case of volcans, there was very complicated to tell what gases are inside. So the first theories was that it was strongly reducing probiotic atmosphere. Mm-hmm. And most of the measurements in such atmosphere was made by Stanley Miller, which was published in Science 1952. His supervisor was Professor Urey, who is a Nobel Prize winner because he found out the existence of deuterium. But since that time, the information about composition of volcan gases was changed. In 1967, they have found out so-called Fourier transport infrared spectrometer, and people were going to the bottom of the volcan hill. There are such places from which comes out so-called fumarole gases.
So they were measured.
And they have measured this composition and find out that most components of volcan gases are carbon dioxide, water vapor, and about 10% are minority gases, which are compounds of sulfuric, H2S, carbon sulfate. In the case of nitrogen, there was not ammonium because there was a radical HN2. And in the case of methane, there was only very small amount of methane. So I have made the measurement, which in reality, when we look at this composition, it is very similar to exhaust gas of a various system which combusted fossil fuels. It is important to think how it was possible that in the primary atmosphere have about 30 atmosphere, 10% was a minority components, and two main components were carbon dioxide and water vapor. So it was very large amount of carbon dioxide. How it is possible that in this atmosphere there is only very low of 100 ppm concentration of carbon dioxide? What occurred? So first of all, during the contact of our Earth with other object, the
About which
rotation
time,
axis
about which
changed.
time we are talking now, approximately?
About 4,5 or 4,2 milliard years ago.
Okay.
In that time, there was a rotation axis to change to about 6% in connection to the plane of ecliptic. And it means that we have 4 seasons, and during the winter there was very low temperature on the poles, and it began to condense the water. Practically then, due to convection, was the temperature of surface of air decreasing and occurred the condensation of water. But there was very high concentration of carbon dioxide. We can see around the volcans also nowadays.
Yes.
The number of sparks, I mean spark lightnings, was strongly raised, up to 3 orders of magnitude. And this means that when the spark beat to the sea, and there is not very high level of water in the sea, so a large part of water in the impact of water evaporate, and it sublimate also the bottom surface, which usually was apatite, and from that was released the radical pH4. In the water there is soluted carbon dioxide, so from this occur sugars. But the glucose and similar hexagonal sugars are temperature unstable. Only stable sugar are pentose. It means ribosis and desoxyribosis.
So that is how it started?
Yes. And it reacts with the phosphate. And under the sea level, there was nitrogen, carbon dioxide, and water vapor.
And in the percentage, how many CO2 did we have that time? It was big difference.
15 atmospheres.
Yeah, so it was difference, yeah.
Yes. And it occurred the radical, so-called NCO radical, which dimerize and then react with the water. And from my measurement in carbon monoxide, I know that it occurred malone acid anhydride.
So you did it. Your measurements was like simulation.
I was putting together the measurements which was made in one cell discharge tube to the later model.
Yeah. So it was simulation of the beginning. Yeah.
Yes. And in reality, practically all carbon dioxide was changed to proto cells, which can be the life. But I can explain how it is formed, what kind of construction will be inside. I can also explain how it occurs, the components of DNA and RNA, because it is necessary to have histone-like components, and we produce also histidine, but it is necessary to put the food in and to put excrement out.
Yes.
That I can imagine, but I cannot imagine how occur the replication. With a great probability, it must form a large amount of enzymes which will start this process. But in reality, from all dead cells occur fossil fuels like crude oil.
What we have now.
What we use now.
So the question mark is only about this last part of this theory, yeah?
Yes. But for each case, it helped me to interpret and to find out the processes which can have application in carbon dioxide removal and utilization from exhaust of various sources. Under the various sources, I mean production of electricity, production of heat, production of cement, production of iron, and of course, removal and combustion of waste.
Yeah, and if you are talking about the CO2, what is the most dangerous for the climate change? Where it should be and is necessary to do the utilization for the CO2?
We have to treat the exhaust.
Yeah.
On the output of exhaust from production part to the earth, because there is the concentration high. Perhaps in the case when I combusted methane gas, there is 7% of carbon dioxide in the exhaust. When I combusted perhaps coal, there is about 14%. In the case of mobile sources, there is about 11.2% of carbon dioxide. And there is about the same amount, even slightly larger, the concentration of water vapor. So it means that there is possible to convert this exhaust to so-called proteinoid. Do you know what is proteinoid?
What does it?
I have amino acid.
Yeah.
When I have a polymer, there are only amino acid. It is in reality perhaps meat.
Yeah.
So it is a linear polymer. When there is incorporated also other components, it can be perhaps DNA. Because I have there sugars, I have the residue of phosphoric acid. But when I have quite a lot of components, and they are even cross-linked, it is proteinoid. There is the mixture of various components, and it have also electric dislocation. So it is something, when I look at it, it looks like the powder, but it is not the powder which is solid inside, it is hollow.
Yeah, so where you can use it?
Perhaps it can be used as an additive to soil, which can improve the properties of soil.
Yeah, by the bio.
And of course, not only as the source of various components, but also it helps to store the water from rain.
Oh. And how it is possible?
Because there is a lot of hollows, and it is like sponge.
Okay, so in combination with the soil, to put it in the soil, it could manage that it will be like sponge for the water.
Yes. And it is very important because during global warming, we will have a problem that it will be days when it is raining all the day, and there is quite a lot of water and overflow. And there will be, of course, also days where perhaps 1 month without rain, or even more.
Yeah, so if I could understand, with utilization, you can take the CO2, you can get the oxygen, and then you can get the powder we can use for the soil.
Yes.
Yeah, so it's built like ecosystem.
And it is also suitable to use as a food because it contains quite a lot of proteins.
So also for the people,
I don't think that people want to eat it, but it can be for chicken.
Yeah, for the chickens.
Or such things.
So you can have it as a feed for the worms. Yeah.
For the worms.
So you can use it as a protein food for the worms.
Yes, of course.
So if you have worms,
and then we can eat worms.
Yes.
Or we can give the worms to
the chickens.
Chickens, but the chicken can eat also this without intermediate. Worms.
Directly they could eat it. Yeah. So not only worms, but if we will put to the worms. You mentioned that the worms...
We can perhaps mix it with some plants which are given to chicken in green form, make a mixture, and they will eat it together.
Yes, there's also Greenway, where we are bio.
Yes.
And then people are eating these chickens or worms, and it's very healthy for us in this case.
Yes. But in reality, I will use 3 systems during the utilization of carbon dioxide.
Which systems?
One system is the electric discharge, which is burning under the level of water, and the low voltage electrode is immersed in the water. So all components which are soluble in water can be through the electric wing given to the water. And then gas will be go to discharge system, vertical discharge system. It will be changed to this powder of proteinoid, but the water will go to electrolytic system with membrane, where it will be changed in the similar way as it is done from syngas to produce hydrocarbons using so-called Fischer-Tropsch synthesis, which is known from 1923.
Oh, really? From 1923?
Pre or Second World War, it was used to produce fuels for cars.
Ah, okay.
And exists such system in Poland.
Yeah.
But this need that the exhausts are very clean and there shouldn't be carbon dioxide. But in the electrolytic system, there is no problem with the carbon dioxide. So it is changed. Now it depends the length of chain, carbon chain. When it is higher than 30, it is wax. But it is possible to use additional catalyst on the base of nano-sized carbon, which will produce components containing C15 to C21. It is petrol and diesel fuel. So it is possible to produce diesel fuel using this method. So it is a so-called e-fuel.
Yeah. What can be used everywhere.
Sure.
And when we are now talking about this fuel and about the engine, what do you think that it is true that to kill the diesel motors will save the planet and to solve situation with climate change?
It is very funny because in reality, diesel fuel and diesel engine is better than auto engine using petrol fuel.
Why?
Because when you combusted petrol in auto engine, you must have three-way catalyst. And the three-way catalyst in reality increase the amount of carbon dioxide, about 1.4 times.
Oh, really?
And it works in a stoichiometric ratio. It means to one piece of fuel, you must give 14.6 pieces of air.
Yeah.
It is stoichiometric degree. But in the case of diesel, you can have, and particulate producing in auto engine are much smaller. They are so-called PM2.5. So it means that they are smaller than 2.5 micrometer. And our pulmonary system has all pipes which have a distance, diameter 4 micrometers. That means everything which is smaller than 4 micrometers, we breathe.
Yeah.
Also the particulate from auto engine.
Yeah, of course, so it's more dangerous for us.
But diesel engine produces particulates which are so-called PM10. It means that they are bigger than pulmonary system. And auto engine produces carcinogenic benzoapyrene, which is second most carcinogenic compounds after methylcholanthrin. So in reality, from the point of view of our pulmonary system, it is auto engine worse than diesel engine. But diesel particulates are soluble in saliva. So when a part of yeast is solute and we eat it, it can produce not cancer of lung, but cancer of stomach.
Yeah.
So from the point of cancer, there is no very big difference between diesel and between auto engine.
Yeah, because it's dangerous anyway.
It's dangerous anyway, but auto engine is from the point of global warming worse.
Yeah, and that's the point where we have to look now.
And diesel engine has a higher production of NOx, but practically zero production of carbon monoxide. and lower carbon dioxide than auto engine. And it is necessary to tell that it is different because diesel engine has lower revolution than auto engine. Auto engine has a nominal revolution about 3,500, but diesel only 2,000. But it is bigger stroke volume in the case of diesel engine. So in the case of diesel, it is possible to find removal of NOx, usually adding either AdBlue or recycling exhaust gases. But there is also possible to have turbo systems, which in reality use kinetic energy of exhaust to bring turbine to movement and compress the sucking air to 30 atmosphere, and then it will work as a lean mixture.
And when I go back to your beginning, when you was doing measurements at the beginning, and now we were talking now about these engines and the differences, what did you find out at that time, and what you were spending time, and what you find out? What was the result at that time?
In reality, I was able to remove particulate. It means the problem of particulate is possible to lose. Because when I catch the particulate, we cannot breathe it. It will be not in air. But that time nobody wanted.
That time nobody wanted, and now they would like to, yeah? They would like to pay
Yes.
for that.
Yes.
Yeah. Why do you think that they didn't want that at that time? Do you think that they didn't recognize that it's so important, or nobody was trying to solve that solution at that time, or they didn't see as a problem?
You know, Czechoslovakia at that time was a socialist part.
Yeah.
And all the research which was done was possible. You cannot do what you want.
Yeah, that time you
couldn't. Have to do what
they ask you to do.
They ask to do. Some people do also research which was not asked.
You was doing, yeah?
Yes.
Yeah, that time. But you was doing, it was
parallel system to catalyst.
Okay, the same.
Because it was not possible to stop the production of catalyst that time. Because catalyst already exists and it works quite good on carbon monoxide.
Okay.
And particularly also on nitrogen oxides. And my system will do the same work, but they want to have additional work because this was already a result and works everywhere.
Yeah, but what you did was better.
Yes, but it is interesting only now when they look also on carbon dioxide.
Yeah, I got it. Yeah. Okay, so when we compare now...
So you want to compare
the
various type of mobility which up to now we have.
Yes.
So first of all, we have, of course, diesel and auto engine motors. For persons, there are these two possibilities. But in the case of transport of a large system, there is in reality only diesel engine, because in the boats there are diesel engine TIR, there are diesel engine buses, there are diesel engine. Because always when we need to have a big power, it is not possible to do with benzene engine. Usually they use diesel engine. So when they want to change in Europe the diesel engine to remove it from the market, in the case of this big system, it is not possible. Similar in rail, it is not possible.
Yeah, but it's also not solution.
It is not the solution. There is the possibility to use in such system proton exchange membrane fuel cell systems. It in reality use electrolytic system with membrane, and there are various electrodes, and it put inside the fuel. In the first application it was hydrogen, and convert it to electricity and heat. When we compare perhaps the efficiency of combustion engines, which lie somewhat between 27 to 28 percentage. In the case of proton exchange membrane, it is 42 percentage of electric energy and additionally 42% of heat, because the product is a water vapor at the temperature 80 degrees.
Mm-hmm.
So when we condense the water, we gain the heat which is possible to use.
Yeah.
So in the case of buses, in the case of TIL, in the case
Rails
of
also?
rails, and in the case of boats, it is possible to use these systems, which has a much higher efficiency than combustion systems. And in reality, it was applied and used in the case of buses and in the case of TIL. Of course, there is also the possibility to still use the diesel engine, but with the so-called air fuel.
Yeah, so it's possible to use it, yeah.
Yes, usually it is produced from syngas.
Mm-hmm.
And syngas is produced by gasification of fuel. There is higher efficiency. When I gasify and then combust the product, I have much higher total efficiency.
Yeah, so it's better to go to this way.
Yes, in the case of diesel. Then we have other possibility that we can use compressed air in diesel engine.
Yeah.
It exists a company in Nice which is producing a special system. They use wind turbine to compress the air and then use in the diesel engine without fuel only compressed air.
So it could stay, the diesel motors will stay. We will just use the air instead of
fuel and air.
Yeah. And they are already working by that way and it's successful.
Yes. But the car is not very nice.
No?
No.
You didn't like design.
In French, it is absolute mistake.
Yeah.
And then it is possible to have an electric car, but there are two problems. First of all, lithium-ion batteries are very heavy. So when you want to have a car with a lithium-ion battery and electric power, then you have 450 kilograms is the weight of battery. It means that it influences the safety of such car because bremsing distance is bigger, of course.
And also the lithium batteries you cannot destroy.
Lithium-ion batteries are flammable when it is very hot.
Yeah.
It means in summer when we have perhaps 45 degrees
it's
outside,
dangerous. Yeah.
It is dangerous. And also in winter, the total capacity decreased to 30% of possible because it is very cold. But the biggest production of lithium-ion batteries is in China. There are two companies, Jet and CATL, which producing this battery. And the company CATL began 2 years ago produce special batteries which are not lithium-ion but sodium-ion.
And it's better?
It is much better. First of all, it is possible to gain sodium from salt water.
Yeah. And liquidation of this battery is
no problem.
Yeah. Like with lithium.
There are electrodes which don't contain chromium because they are from carbon.
And can I ask you something? When we are talking about electromobiles and CO2 for the producing cars, we are talking about really, really high number of CO2.
When you look on the life cycle assessment of such system, the carbon footprint is very big.
Yeah.
Because the production of lithium means many steps of concentration of lithium. And this is without electricity, it is not possible. And without heat, it is also not possible. So the production of battery is very big producer of carbon dioxide. In reality, when we look at the life cycle assessment, it is bigger than when I produce diesel.
Diesel, yeah.
There is a problem, and sodium-ion batteries are slightly heavier, but has about the same energy content and are 5 times cheaper and have no problem in summer, neither in winter. And they are possible to be charged in 5 minutes.
Oh, that's great, in 5 minutes. Yeah.
So when begin the use of sodium-ion batteries, in reality it means that it can improve and help to application of electromobility.
And how
But
often you need to change the battery then, sodium and lithium?
usually the lifetime of such battery is somewhat between 10 to 15 years.
Okay.
But there is one other problem. When we want in a large number to apply the electric mobility, it means that we must find the sources of production of electric energy which can be used to charge these engines. And we will need about 5 times as much energy as we have now. In some countries which have a large amount of wind turbines, they use the excess of electricity from wind turbine in special times,
For example,
for charging of
Yeah.
batteries of car. So it can be used as an intermediate system in between. Up to now, I don't see it very positive. There is also the possibility to use a hybrid system, which have a combustion system as well as electricity. And this hybrid system, from the point of view of carbon footprint, is much better than electromobility.
So combination is
Combination
maybe the
seems
best
to-
version.
It is always so. When you have a combination, it is always better than monothematic
Like we were talking
system.
also about energies, when you have
But
combination.
the company Daihatsu, which is the oldest Japanese car production company, have a patent using proton exchange membrane fuel cells, but not fuel using hydrogen, but fuel using hydrazine hydrate.
And this is much more better?
It is the best.
For the market is the best now.
I don't think for the market, but from the point of view of carbon footprint, it is absolutely best. Small cars, which we can compare to motor with a stroke volume about 1.6 cube centimeter. And they must be able to park in a very small place. And now they begin to produce cars which are, in comparison to 3.5 stroke volume cube motor, and it can be suitable for very small companies in the towns.
Yeah, so it's also one part solution in this case.
Yes.
Okay, so this is the most sustainable from all these cars we were talking
I
about.
think that we have to think that in future we can make a combination of electromobility with hydrogen energetics in the case of cars and hydrazine. When you want to drive 500 kilometers, you need only 5 liters of hydrazine hydrate.
Oh, really?
Really.
So it is also cheapest way.
Yes.
Not only the best for climate,
Yes.
but it's also
Yes,
the cheapest
sure.
way.
And each house has nitrogen and water vapor. Because hydrazine it is NH2, NH2 plus water.
That's all.
That's
You have
all.
that. Yeah.
And it don't need the noble metals as an electrode.
It's not necessary to have
No, they use electrodes from a special type of crystals.
So it's enough to have it.
So-called perovskite crystals. The largest laboratorium for studying perovskite crystals was in Belgrade, but during the war it was bombarded
Okay.
and destroyed.
And it was the best
It was the best in the world.
in the world. That's a really big pity. You was really also a lot traveling. You was in Japan, you was in Sweden, also in the United States.
Yes.
In France also.
Also in Germany.
What was the best for you from all these journeys?
From the point of view of quality of laboratory was the best in Sweden.
In Sweden.
But from the point of possibility for researchers was best in the US.
In US it was the best? And what you did there in the US in that time?
It was the cooperation between two laboratories working in the area of plasma physics. So
And which university it was where you was?
it was in Minnesota, the university, and the group was from most of laboratory persons were from Germany.
From Germany.
Mm-hmm.
So you did also for the plasma
Practically,
research?
my technology is based on plasma physics.
Yeah. And when you was in Japan?
In the Japan, I was in a very good laboratory, but there was the problem because Japanese people are very weakly invented, but are very precise.
Mm-hmm.
So they are trying to find suitable people through Monbusho Stipendium and find people who are very good in invention and help them to produce the system till the end.
Yeah, so in that way they are really good.
In that way, they are really good.
And what was in Sweden the best for you?
I have the best supervisor there
Okay.
because he built in Studsvik the best motor test centrum for testing of cars, and it was absolutely perfect. And he knows about cars, I think everything. I have learned from him very much.
So can you repair your car?
When I have old seat, I repair everything. Now I have no time to repair anything, but I have a perfect person who will repair for me everything.
Yeah, but you are able to do that without any problems.
Especially I am looking on everything when he repair. I am looking how it looks like, what is it inside.
But it's very special, for the woman to have this interest in the motors.
I like cars.
Yeah. Also the nice noise of the 3-liter engine.
Sure.
Yeah, me too. Yeah. So we are not so from this point of ecological
But
way.
I always told me, when I want to use car, I must every year seed 20 pieces of wood, warriors.
Ah, okay. That's
so
nice.
I was quite a lot of interesting using vertical planting in the buildings, and I have on my balcony maybe 30 pieces of various trees and small trees and miniature trees and some vegetation everywhere.
But this is the way when we are using that we could to do the
Do
plant.
you know how it is nice in the summer when I go to balcony?
Yeah, I believe. Nice flowers, and you are enjoying that. And you were also the worms, what I remember on.
Yes,
so
I have a special system
composting.
for composting using vermicompost. They are working very effectively.
Yeah.
Usually in 3 months I have humus.
Yeah.
And it produces also the liquid, which is possible to use as liquid food for vegetation.
Yeah, so you have really nice ecosystem in this way.
Yes.
And I remember what you told me once with worms about methane.
Yes.
Yeah, can you
when
tell
you
that?
compost, you produce from 1 ton of biomass 500 kilograms of carbon dioxide and 230 kilograms of methane. But in the case when you make vermicomposting, you don't produce any gases, neither carbon dioxide, neither methane. You produce humic acids, which are the main component of humus.
Yeah, but this is the solution also
for
the future, because when people will have more worms, they could have more food for the chickens, then the chickens are healthy.
Sure, but most of the people, when I talk about vermicomposting on flat in balcony, they told, it is dirty. When it is in soil, for them is everything dirty.
Yeah, I understand, but if when you have in the soil, they are happy.
I told
they have luxury place.
I have to wash my hand after that.
Yes, of course, you are washing, but you are doing good thing. In each person would have it on the balcony. Yes. They could save also the methane from the atmosphere.
Not only.
Yeah, not only.
But the composting using worms should be instead of classic composting.
Yeah, it could be a big solution for that.
Sure. But in reality, when you look on the system, they store or food residue from the families, but it will be composted classically.
Yeah.
I have the students who is working in the company which is doing this, and he told me that he is angry because he learned from me that vermicomposting is better, and he must to develop the system which is classical.
Oh my God. But you know, this is the worst thing when you have knowledge and you know what is the solution, the best solution, and you have to go with the rules and to do by the people who made these rules without that knowledge,
Yes.
we could say. And when we are talking about also the waste, what you see as a solution, how to work with the waste, what to do for the future to also eliminate CO2 and
You know, I have developed the system for gasification with plasma, and we have also valid area for that system. It is for 100,000 tons per year, but in reality it doesn't exist such system in Slovakia. And during the EIA process, we have quite a lot of problems because people don't understand.
if
That's
they
the
don't understand,
problem,
yeah,
and they are under the influence of the people who are green people, but they have no enough knowledge, and they speak that it is not good.
yeah, and
Everybody wants only to have storing the waste, and
yeah.
it is
But
terrible.
this is not solution at all.
Do you know how
Yeah.
many rats? Normally it is so that we have one rat for about 3,000 people. But in the surrounding of the waste storage,
Yeah, on the waste.
there is 100 rats for one people,
Oh, really?
really.
I don't know about that.
And
numbers.
of course there is also quite a lot of birds
Yeah.
which are coming to that and eat everything.
Yeah, I saw the seagulls when you are passing the
Yes.
story.
And then in the inside of intestine, it is a mutation of viruses. Perhaps the mutation of grippe or COVID can be in the birds, and they fly and excrement comes down.
Yeah, then the rats are there, and the combination of
Yes,
these rats and birds.
it is not very,
it's very dangerous.
good combination. It is dangerous, but nobody wants to hear such voice.
Yeah, well, this is very sad, I guess,
Yes.
because there might be really a lot of solutions, and with these bacteria, viruses could be destroyed really, and could come new virus.
Sure. In reality, in our intestine, we have about 3,500 type of viruses, from which only about 700 are known one.
Wow, it's a huge number. And we in Slovakia we started also with the recycling bottles. Mark Zit, I would like to ask you how you see that, if it's really sustainable, helpful.
It is necessary to tell. When I have the bottle, it can be recycled only 10 times. Because it increases the crystallinity of the system,
Yeah.
it should be amorph. But when the increase of crystallinity is through that, it is like the hollow, very small hollow, and the bacteria and viruses can go through to inside of the bottle. That's the reason why it can be recycled maximally 10 times. After these 10 times, it is used for some drogistic things. Then it is produced from that the sitting plastic.
Yes, sitting plastic,
and also some
or some
boxes,
floors, boxes,
floors and
but not
boxes.
for the drinking bottles. Mainly oceans. There are a
Yes,
lot of.
and this is not possible to recycle, so it is necessary to find a way what to do with it. But the combustion energy of PET bottle is 1.5 times bigger than for coal and also for methane. So it is very good fuel. When it is not burned but gasified, and the syngas is then burned.
Yeah.
It can be very effective method for producing of heat
Yeah.
as well as also energy.
As a e-gas.
Now I should have the invited discussion in our Ministry of Environment about pyrolysis and gasification.
And were they listening you and trying to find this way for the solution?
I want to modify their knowledge.
Yeah, that's really cool. I think that is very important that you are doing that.
Because
But it must be on their side to have interest to
yes,
get
it
the
was
knowledge.
on their
It
side
was.
story. Two persons from the ministry was in my laboratory and agreed that I will have some.
This is really good. Yeah, because with the courses and education, when you could educate those people.
People saw that in reality we have whole our life to educate. But some people don't want it.
Yeah.
Because they think that after they finish the school, they are now free and don't need to
And they know
do
everything.
anything.
Yeah. Thank you very much for
It
the
was
talk.
a pleasure.
It was really pleasure for me that we could know all this great information, and I'm looking forward to meet you again with next part of talks. Thank you.
Okay, thank you.